Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not have this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 283. Page 283, today is our lesson number 116. Problem number 92 is what we want to look at. In problem 92, we are given 4 integers, a, b, c and d, and we are told that they are all positive. The question they are asking is simply, is a over b less than c over d? Is the ratio of a to b less than the ratio of c to d? That's all they are asking. In the first statement they tell us that this quantity, c minus a, the difference of c and a divided by difference of d and b, is positive. Now when is the fraction positive? A fraction, any fraction, is going to turn out to be positive under only 2 circumstances, under only 2 scenarios. One is that when top is positive and the bottom is positive, then the fraction is going to be positive, or when the numerator is negative and the denominator is negative. When the top and bottom, they are both negative, negative divided by negative is positive. So let's look at these 2 scenarios. We're going to contemplate different situations by plugging in numbers and see what happens. For example, in this case, the only way the top can be positive, the only way that numerator can be positive is if c is greater than a. So we plugged in c minus a, we plug in 6 for c and 2 for a. Here, c equals 6, and a equals 2. So 6 minus 2 equals 4, and we plugged in 8 for D and 3 for B. 8 minus 3 is 5. 4 divided by 5 is positive. But what happens here? If you look at this ratio, A over B is going to be 2/3. A over B is going to be 2/3. And similarly, C over D is going to be 6/8. It's going to be 6/8, which is same as 4 quarters. Oh, sorry, 3 quarters. I didn't mean to say 4 quarters. And if that's the case, we can clearly see. If that's the case, we can clearly see that 3 quarters is greater. 3 quarter C over D is greater than A over B. Here I have it in the opposite. I have it written down in the opposite way. But 3 quarter, of course, as you can see, is greater than 2/3. The question here is AB less than CD? Is AB, which is 2/3, is 2/3 less than 3 quarter? 2/3 is less than 3 quarters. So here, in this scenario, the answer turns out to be yes. But what happens if it turns out in a different situation here? Top has to be negative, bottom has to be negative, which means C minus A has to be negative, and D minus B has to be negative, which means D has to be less than B and C has to be less than A. So here we're dealing with the situations where C is equal to 2, C is equal to 2, D is equal to 3, A is equal to 4, and B is equal to 6. Of course, you can plug in any number you want. These are just numbers that we're dealing with here. So in this case here, C over D equals 2/3. And similarly, A over B equals 4/6. Well, 4/6 is 2/3. So here they are all equal. So the question was, is A over B, which is 4/6, which is same as 2/3, is 2/3 less than 2/3? Of course, 2/3 is not less than 2/3. Here, C over D is same as A over B. So in this situation, under this situation, the answer to this question is no. C over D is not less than A over B. Here the answer was yes. C over D is C over D is greater than A over B. So depending on what the values are, we can't really tell, we can't answer this question. Now these numbers that you see here that I plugged in here, these are not numbers of my own. These are the numbers that they're employing, these are the numbers that they're using in the back of the book. If you look in the answer choices and the explanation, this is what they use. I myself would have liked to approach this thing in a little bit different way. I'm going to show you what went through my mind when I was looking at it. Instead of doing all this thing and then asking yourself, do we see a contradiction or not, what I like to do is start out with the contradiction. In other words, reverse engineer the whole thing. You've heard of the concept of reverse engineering, where somebody who's industrial espionage, they call it, where they buy the product made in some countries and they bring it to their country and then they take it apart from the top down and see how the whole thing is built. It's called reverse engineering. That's what I would like to do here. Here's what's going. As I start doing it, it will make sense to you. Here's what you do. I need the room, so I need to erase all of this thing. I'm going to give you a couple of seconds to actually pause the video if you have to and take it down. Now you understand when I say that I'm going to give you a couple of seconds to pause the video and take it down. That's just euphemism I employ to tell you that I need a sip of water, a sip of tea. So here's what you do. Reverse engineer the whole thing. The question is this quantity less than C over D? The reverse engineering, what you do is you start out with a contradiction. You make them equal to this thing. If they are equal to each other, then the answer is no. Is that A over B is less than C over D? Well, if you start out by making them equal, the answer to that question is no. And see if it's possible. And then you do another scenario where you see the contradiction. You'll see what I mean. Just here's what you do. So A over B, let's make it 10 over 5. 10 over 5 and 8 over 4. The question is, does this fulfill our condition? Here, our condition is, which is the first statement, which tells us that C minus A over D minus B is positive. Well, does this satisfy the condition? C minus D, C minus A. This is your C, 8 minus A, which is 10, over D minus B. D is 4. D is 4, as you can see. D is 4. And B is 5. 8 minus 10 is negative 2. 4 minus 5 is negative 1, which equals positive 2, which is 0. Yes, so we fulfill the condition, and yet we have shown the situations where these two are equal. Now let's look at situations when they are not equal to each other. It doesn't matter which one is greater and which one is smaller, as long as they are not equal to each other. Let's look at second situation. In the second situation, we will start out by, so here this was situation, A over B equals C over D. Let's look at second situations where we'll make A over B less than C over D. Now I did less than, you don't have to do less than, you can do greater than. All you have to do is see if it actually works, see if you can make it happen. And if you can make it happen, you will have the contradiction, then the answer is no. Can you tell which one, is this less than that? The answer is no, because here is equal, here it's not. You just have to be able to show that that is possible. So here we go. 2 over 6 rather. 2 over 6, which we know is 1/3. Is 1/3 less than 5 halves? Of course 1/3 is less than 5 halves, because 1/3 is, well, 1/3 is less than 5 halves, because 5 5/10 equals half, and of course half is greater than 1/3. Now let's see if it works here. Here, C minus A over D minus B, your C is 5, your C is 5, our D is 10, over our A is 2. I'm not paying attention. C, which is 5, C is 5, minus A is 2. And then D is 10, D is 10, and B is 6. It gives us 3 over 4, and 3 over 4 is positive. So we fulfill the condition. We fulfill the condition that this quantity is positive, and yet we find the situations where here it is less, and here it was equal. So which one is it? Or rather, here it was equal, and here, I'm going to erase one of these things. Voila. In one case this ratio is less than that, in this case this is equal. So which one is it? The answer is we can't tell. Therefore the first statement is no good. Therefore the first statement is no good. This information that they give us is of no help to us. It is no help to us because one time this ratio of A over B happens to be less than the ratio of C over D, and the other time they were equal to each other. So we can't answer the question, is it always less than that? Since the first statement by itself is not enough, the answer cannot be A or B. Sorry, A or D. See, I wrote down wrong because I wasn't talking at the same time. I have to speak to myself. A, D, B, C, E. Since the first statement by itself is not enough, the answer cannot be A or D. Let's look at second statement, shall we? So as you understand, I did this problem, I did the first statement that we just finished. We did it two different ways. The first way I did it by using the same number. I just copied all the numbers from the back of the book. I cheated. I went to the answer choices and the explanation, and I copied all the numbers, and I showed you how they are explaining the situation. And then I showed you what I would have done. Reverse engineer it. Start out with a contradiction and ask yourself, is this contradiction possible? Start out with two different scenarios with the contradiction. In one case makes the two ratio equal to each other, and in the other case make one ratio in another case make the two ratio not equal to each other. It doesn't matter which ratio is greater, which ratio is smaller. It doesn't matter as long as they are not equal to each other. If in one scenario the two ratios are not equal to each other, and in other scenarios two ratios are equal to each other, and if you show that both of them satisfy the given condition, then it's not sufficient. That condition is not sufficient. Now let's do let's do the second statement. Second statement, you will find, is not that much of a hassle. It's a very straightforward algebraic manipulation of two steps. Very simple. They tell us that AD over BC squared equals, is less than AD over BC. So this squared thing is same as AD over BC times AD over BC. I see AD over BC here, I see AD over BC here, just cross them out, and you end up with AD over BC is less than 1, because this is just 1 now. Cross multiply both sides by BC, cross multiply both sides by BC, then AD is less than BC. And the question was, is A over B less than, so divide both sides by B now. This B drops out, divide both sides by D, and this D drops out, and you end up with A over B is less than C over D. Voila. Which is what they were asking. The question is this quantity less than this quantity? The answer is yes. Very simple, very straightforward. And what allows us to be able to multiply and divide by this quantity here? That is the fact, because they tell us that they are all positive, which is why they go out of their way to tell you that these integers are positive. If these integers are not positive, if A, B, and C, if we were not told that they are positive, we couldn't have done this manipulation. We couldn't have divided both sides by B times C, because multiplying potentially by a negative number changes the directions of the inequality. But this works. Therefore, the second statement works. The answer is B. The answer is B. And that's all. Let me quickly check in the back, make sure it is B, 92. The answer is B. Alright? I'll see you tomorrow. Bye now.